who am I? Very quickly, I'm an industry analyst, consultant and futurist. I've been to all of the TAD Summit events, and I'm generally considered a bit of a thorn in the side of various parts of the telecoms industry because I take a fairly controversial stance on most things, hence my Twitter handle of Disruptive Dean. I look at evolution of networks, so wireless, 5G, spectrum policy, all that stuff. The middle box, one of the middle boxes is more relevant here on voice, video, communications, CPaaS, UCaaS, and all the rest of it for communications, apps and services. I've looked at future of voice in particular for the last 10 years. What I call telecom futurism, which is the intersection of all this with things like IoT and VR, AR, what I'm talking about today, blockchain, and also AI, and I publish some stuff. So, next up. Yes. Right. There was a version of this slide that Rob Pickering presented yesterday. What I see in telecoms, and this is not just sort of telecom operators, but the whole of communications and networking, is a tension between two different directions of pull. On one side, we have what we've been hearing about here, which is decentralizing things, democratizing technology, enabling developers, enabling arbitrage between multiple services or networks. And then on the other side, there's this sort of pull to centralize things, whether that's standardization, whether that's the consolidation of big telecom companies looking to bring things in-house. Some aspects of federation, I would say, are on this side as well. I'm a big fan of divergence rather than convergence, although the two go hand in hand. And against this backdrop, you have all these other trends, whether it's 5G networks, whether it's mobile content, whether it's browsers, Internet of Things, AI especially. AI is interesting because it's sort of mostly on the centralizing side of things because of the need for large amounts of data, and obviously typically a single purveyor of algorithms in most cases. So it's worth to bear in mind this tension is not going to be resolved by either side is winning. For everything you look at in telecoms, there's going to be this sort of tug of war between these two sets of trends and dynamics. So, blockchain. Hands up, who knows what blockchains are on distributed ledgers? Right, so it's about half the room. Right, I am not a developer, so I'm going to give a 30-second overview, which is going to make some of you wince and some of you hopefully not too confused. Essentially, it is a decentralized, self-verifying database. There are various forms, I'll come into it in a minute, of blockchain technologies or distributed ledger technologies. But the basic principle is that rather than having a central database authority, think of a bank with a bank account or a government with a numbering resources for a telecoms network, or frankly, it could be a government with a voter identity database as well. But you have a central authority. Rather than having a central authority, you distribute that database amongst multiple parties. And it can either be anyone, or it could be a particular set of parties interested in a given problem. The idea being that you reduce the risks of that central authority getting stuff wrong, or charging excessively for access to the data. And this sort of implicitly changes the nature of trust in data and transactions. Now, the key thing here is this word validation, validate. And there are a lot of variants of who does the validating. Yes, if you have no central authority, you need to have some mechanism to validate data and transactions. And you therefore need to have computers or people to act as that network of validators. And they need a good reason to do so. And that reason can either be you offer them a reward of some sort, payment of some sort of kind, we'll come on to that in a minute, or they are mutually self-interested in validating the data. The term chain just comes because usually the transactions get batched up into blocks, and so you have a chain of blocks of transactions, and there is some mechanism for validating each set of transactions. So that's a sort of horribly simplistic, but hopefully sort of decent basic intro to how distributed ledgers work and why they're useful. This thing about changing nature of trust we'll come back to. So a little bit more here. there are lots of different sorts of what are called distributed ledgers. Where you see something talking about the blockchain, and people talk about putting stuff on the blockchain, it usually means the original underlying chain underneath Bitcoin. Where it's called a blockchain or a ledger, then you start to get into a whole different set of technologies and communities. And the other divide here is between public and private. A public blockchain is one that anyone can participate in with a computing node to become a validator. And a private one, sometimes called permissioned, is one where there is maybe a consortium or a small group that mutually decide on rules for who could be inside that. So you could imagine a trading community of a company with its suppliers. It could be a number of telecom service providers who are reconciling traffic between them, but there's essentially some form of membership. There is a permission. So common examples of public blockchains, Ethereum, which I think we'll talk about later on today, is probably the one which is in some ways most important after Bitcoin. And it's most important because it is a software platform that allows other applications to be written on top of it. And this is the thing here, is that you can start putting software applications, sometimes called distributed applications. This term smart contract will crop up, where essentially you are not just validating the data, but you're validating what gets done with it. And that could be creating a new sort of almost like a subsidiary chain or token off of the core one. So in the interest of time, I'm going to have to push on. You tend to get a little bit of religious war, I should say, that some of the sort of people on the public side of blockchains look down on the private and enterprise ones, which, to be honest, are more realistically described as sort of glorified and decentralized databases. But that doesn't mean they're unimportant. And in many ways, I think that the right-hand side is more relevant in telecoms. So why would you use these? Apologize for the text slide, but just to sort of go through, I see a lot of, there's an enormous set of possible use cases, and I'll go through a couple of examples. But at a very top level, looking at the telecom operators or maybe CPaaS providers or other software companies, frankly, a lot of the stuff is not necessarily about customer service. It's about improving existing mechanisms of doing things in the machine, either within one company or between groups of them. And a classic one is going to be things like automating billing and settlement for interconnect between telecom companies, which is a boring, complex, expensive task which needs lawyers and lots of duplication of effort and could be automated better. And there's a few others which essentially are, it's a classic sort of technology thing of how can we improve our existing systems. There's some stuff around reinventing network technology, which I think is perhaps a bit of a sleeper here in terms of what really is a game changer. And there are various people trying to reinvent everything from IP to wireless networks to buying submarine cable capacity. I spoke to one company recently. So there's a fair amount of sort of work that's done at the underlying network plumbing level. The focus, and I suspect the focus here, is around the customer-facing services, either for service providers or developers or others. And there's a lot of work that's going on, which could be anything from mobile payments to improved use of improved ways of doing temporary roaming contracts for mobile users, to potentially having decentralized. There's a couple of people trying to do decentralized PBX or cloud telephony platforms. There are literally hundreds of possibilities here, especially around things like Internet of Things, where you'll find this is sort of on the fringes of whether it's telecoms or not. But there's a lot of things of people say wanting to trade electricity between a car and the solar cells autonomously. And the last one is where you have service providers doing stuff in other people's blockchain-enabled ecosystems, where there might be a need for voice communications, where there might be a need for a service provider's connectivity, so they might be providing a blockchain-optimized network that does edge compute. There's a bunch of other things where there are possibilities for telecom companies of all sorts to participate in. The more complex version of this slide is this matrix, which you'll be pleased to know that I'm not going to talk through, except to say that the way I want here is I've basically thought about the verticals are bits of the telecoms industry, and you can, if you like, double-click on any of these to get more granularity, from the network to the voice calls and platforms, communications, content, cloud services, and the horizontals are rough things you can do with blockchain and distributed ledger technologies, whether that is guaranteeing integrity of data, so can you prove that a piece of data hasn't been changed, which is really important for things like Internet of Things or anything where you, for example, might need to have a proof point that the call detail records haven't been altered. And one of the things that blockchains allow you to do is to create tamper-proof architectures where you can prove the provenance of a piece of data over time and show that it hasn't been changed. Disintermediation of varying services, if you're removing a central authority, it comes by definition. Identity management was talked about before. Anything to do with a registry, wherever you've got a registry, it could be it could be to do with numbering, again, is a good example, but it could be a registry of spectrum licenses. The Indian government is looking at one for permissions to opt in for telemarketing messages, this sort of thing. So you might have a registry of people, of things, of assets. And all of these go across the different verticals. And as I say, this is fractal. You could double-click on any of these. The red dots are a very rough sort of heat map of where I see people talking to me most, but there's probably stuff going on at all of the intersection points. So, tokens and tokenization. So we talked a bit about the private blockchains, which essentially are shared databases between multiple parties. This concept of a token comes up, which is where you verge into the sort of cryptocurrency aspect of blockchain, where you actually have a way to store value. And in a way, we're used to having non-monetary ways of storing value. I expect people here, some of them are in the frequent flyer scheme. So you will be using essentially a non-monetary way of storing value that can be later used for buying flights or hotel rooms. Go to a casino, you get given a non-monetary chip. So we're used to using tokens of varying forms to express value, store them. And the interesting thing is they all have their own rules and economics. So for frequent flyer points, there's usually a set of airlines that give them under certain rules where you get a certain number for a particular flight, they can generate. There is not usually a fixed pool of frequent flyer points, so there isn't necessarily an inflation problem. Whereas you have other things where you might have constraints. So a barrel of oil, there's obviously constraints on supply, but you can trade and you can essentially buy things with oil if you really wanted to. Or if you're an oil trader, you probably don't get paid in barrels of oil. You prefer to get proper cash. So there are various things that people are doing to what's called tokenize. And create these stores of value. Either this is because it's a good way to incentivize the people doing this validation, or because it's a public blockchain and they want people to buy, well, whether it's file storage or whether it's property management services or whether it's electricity for their Tesla. They ideally would like people to use a file coin or a energy coin or a beer coin or a chair coin. I think on the panel we'll discuss as to sort of where that fits. And there's an interesting discussion about whether you pay the validators in the same coin that you actually transact in, or whether it's a separate and parallel currency. This has been the sort of center of a lot of the hype around cryptocurrency over the last 2 years, because the prices of these have been hugely volatile for a lot of the tokens and currencies. In a way, actually the gambling coins, the casino coins, tokens and chips is a good example. Imagine you were financing the construction of a new casino and you raised money for the construction by issuing people the gambling chips in advance. Now, in theory, people would pre-buy quite a lot of those gambling chips in the expectation that they could turn up in the casino in 2 years when you've built it and play on the roulette table. But what would happen in the meantime is they'll trade amongst themselves, and the price will spike up and down because there's no actual real thing you can do with those chips apart from trade them between them, because The casino hasn't been built. There are no gambling tables. For all you know, they're going to pivot from a casino business model to a hotel, or a sort of a entertainment park. You don't know. And so this is one of the challenges which has driven a huge amount of volatility in the price of cryptocurrencies, and also a lot of attention from regulators over the last couple of years. Come to them maybe if you have time later on or on the panel. So some examples of what's happening real world telecoms related blockchain use cases. Some of these use tokens internally, not as a public currency, but just as a convenient medium of exchange between partners. And that's something to think about. There's not necessarily an open marketplace in these tokens. They could just be used as a good way of communicating between members of a consortium. So wholesale voice settlement, bit boring but important. As I said before, there's lots of duplication of effort. No one really wants to deal with dispute management and have a team of lawyers on staff. Colt and PCCW started this, but there's now a bunch of other partners. They have a blockchain provider called Clear that's doing this, and they're progressively going from one level of proof of concept to the next. And this is an important thing here, is all of these use cases are future. There is pretty much no one in telecoms actively using public or private blockchains in anger in production systems today. There's an awful lot of proofs of concept, there's an awful lot of press releases, there's an awful lot of labs. This is one of the more sort of near-term examples, because it's fixing a clear problem in a fairly understandable way, being done by companies that have good relationships and also fairly visible to external regulators as well. I mentioned the radio network side. I know Alan always talks about, it's all about the services. My view is that it's partly about the services, but it's also partly about the network itself. And there's quite a lot to do about recreating future networks. And there's a whole bunch of organizations at different levels of the connectivity stack. I advise one called Ambertech, for example, that's trying to create a multi-radio mesh infrastructure using Wi-Fi and TV white space and maybe unlicensed LTE to particularly in emerging markets, provide incentivized mesh connectivity, where you could potentially have one node operator getting remunerated for extending coverage in an African village, for example. Obviously, you need backhaul and long-range connectivity as well. But there's a bunch of other people who are really trying to reinvent the underlying bits and pieces of either the internet or the way that wireless networks work. Some have potential, some I suspect are probably overambitious, but it's an area to watch because it has the potential to reinvent the underlying fabric of what we all depend on for the rest of our services layer businesses. Big telcos. Every single big telco has put out at least one press release or a slide deck on what we are doing with blockchain. I've picked KPN from Netherlands here. I could equally have chosen AT&T, I could have chosen SKT in Korea, or a bunch of others. Some are more interesting than others. This one was interesting in that it was more sort of an IT services play by KPN, where they want to do what they're referring to as blockchain as a service, which is really packaging up sort of particularly IBM and Microsoft's own blockchain capabilities, adding in some sort of telco stuff around IoT perhaps, and putting a wrapper around it, and then offering it to their enterprise customers. I'm not quite sure how far they've got with this, but certainly as a concept, they're not actually trying to reinvent the wheel. They're trying to build a car around someone else's wheels, which sort of makes sense. Again, in the guts of the network, there's a bunch of people doing stuff around network function virtualization, things like license management, security. Can we ensure that the software load for a virtual network function is what it's supposed to be, isn't going to do something that we would rather it not? Do we have a record? One of the things I've been talking to telecom regulators is I think that service providers may have to retain records of the state and configuration history, almost like the logs of their network software. Because if something goes wrong, there is no chain of a historical way of reconstructing what went wrong, why, and who's responsible. So is there like an aircraft black box, but for the network, for a softwareized network? I think there should be, from a security point of view. Regulatory is interesting. Various regulators are playing with this. Ofcom in the UK is looking at whether you can use this for number portability. India, I mentioned. And there's various things, people talking about spectrum sharing, for example, and where you need to have a database for who owns what bit of spectrum with what rights and what place, and can they trade them. whole bunch of other use cases which are emerging. Can you do spot markets for connectivity, perhaps IoT, data integrity management service? This is actually a big thing, not just for telcos, but for IT companies. And I was saying before, data integrity is one of the things. I don't care if someone hacks my Fitbit and knows that I have a heart rate of 81 right now. I do care if they change it in a database to 181. Spectrum marketplaces. Basically you drill into this and there are hundreds of possible use cases, all of which are very, very early. And I'll just put this up here as an example of something which is really arcane. The US new spectrum license and CBRS, and there's 9 different potential use cases which could be done for blockchain just for spectrum trading and spectrum management alone in the US. There's also a whole stack. And this is why we come back to sort of Web3. So if you look at Internet of Things, you ever say, Internet of Things, blockchain. But which blockchain doing what? Is it actually the authenticity of a device? Is it about the connectivity for a device? And is it a registry of which devices exist? Is it around managing the software and firmware build and validating it on the device? Is it about the power management? Is it about creating a marketplace for sensor data? All of these are possible other functions, and it's far from clear to me that you'd ever do this all with one blockchain infrastructure. And if you need multiple different chains for the different areas here, how do they interoperate is a non-trivial problem. Yeah, and certainly if you're an IT company, you don't want to necessarily have to have 73 different blockchains or cryptocurrencies reported in your accounts each year. What can you tokenize in networks? There's people playing around with all sorts of stuff, from submarine capacity to SMSs and to voice minutes. Can you share data quotas amongst people? Maybe, but you got to watch out for terms and conditions. VPNs crop up, and can you create a sort of blockchain version of Tor and get people to pay in VPN tokens? Maybe. This slide I could probably spend half a day on, but I'm not going to. Key thing here is there are certain use cases which work well for public blockchains, some which are very clearly for private blockchains, and some in the sort of fuzzy bit in the middle. Roughly speaking, the more people who are involved in sharing data, perhaps writing to a distributed system, the more it makes sense to have a public one. Whereas if it's essentially a closed user group, it probably makes less sense. And clearly, if you're having an open API to developers or media or whatever it is, then you've pretty much pushing yourself into some form of public blockchain space. Unless it's a sort of a closed user group where you're a car manufacturer with 10 suppliers of parts and 20 suppliers of software, and you know who they are and you can permission them. So overall, there's a huge number of possible use cases for blockchains or the wider term distributed ledgers in networks, in telecom services and applications. Really, it's fractal. Yeah, each of these you drill into, and there's 10 possible things underneath it. It's very early stage. There are public and private opportunities. It does have the ability to reinvent trust. I will say that, ironically, for a set of technologies built around trust, one of the things I've found is that some of the world's least trustworthy people are involved in blockchain and especially cryptocurrencies. There's a certain Portuguese startup which still owes me money, which I will not name right now. But if there's anyone here watching this video, you might want to transfer some funds. It is still early days. But there's a lot of proofs of concept, and essentially people need to sort of play around with this. There is no substitute for actually trying stuff out, seeing what works. There are always going to be solutions which are non-blockchain related for the same thing, or which are almost but not quite. But I think that it's understanding the scope that's really important. I am, cautiously optimistic. Frankly, I don't think there's going to be any major disruptions in the next 5 years. I think we're going to see some really cool stuff. Do I think we're going to see anything that changes the world? No. 5 to 10 years, different story. And that's around the same time frame where there's an awful lot more IoT around. We'll have fiber and 5G and better Wi-Fi networks everywhere, so the connectivity is going to be improved. We'll have better devices. We will have sorted out ways of doing these consensus mechanisms which don't take half the world's energy. There's a lot of things that will improve, but I don't think we're there yet. Thank you.
Excellent. Thank you so much, Dean.